Right now, somewhere over the South Atlantic Ocean, a satellite is glitching, not because of a software bug, not because of hardware failure, not because of anything humans built wrong, because Earth's magnetic shield has a hole in it, and that hole just got bigger. NASA knows about it. The European Space Agency is tracking it. Astronauts on the International Space Station are exposed to elevated radiation every time they pass through it. And in the last decade, it has expanded to cover an area nearly half the size of continental Europe, and it is now splitting into two. This is called the South Atlantic Anomaly. It is the largest known weakness in Earth's planetary defense system. It is getting worse, and almost nobody outside of aerospace knows it exists. By the end of this video, you'll understand exactly what it is, why it is happening deep inside the planet, what it is already doing to the technology we depend on, and what it might be telling us about something far larger. To understand the anomaly, you first need to understand what the magnetic field actually is, and why losing it would be catastrophic. 4,000 kilometers beneath your feet, Earth's outer core is a vast ocean of liquid iron and nickel, constantly churning, swirling, convecting, driven by the heat of the inner core and the planet's rotation. That churning liquid metal generates electrical currents. Those electrical currents generate a magnetic field, a field that extends tens of thousands of kilometers into space in every direction. This field is called the magnetosphere, and it is, without exaggeration, the reason complex life exists on Earth. The Sunday is constantly firing charged particles at us, electrons, protons, helium, nuclei, at speeds of 400 to 800 kilometers per second. This is the solar wind. Without the magnetosphere, the solar wind would have stripped Earth's atmosphere away billions of years ago. We know exactly what that looks like. Mars once had a thick atmosphere and liquid water on its surface. Then its core cooled. The magnetic field weakened and collapsed. The solar wind went to work. Over hundreds of millions of years, it peeled the atmosphere away, leaving a thin, cold, irradiated wasteland with an atmospheric pressure less than 1% of Earth's. Earth survived because its core is still churning. The magnetic field held, but it doesn't hold equally everywhere. And right now, there is one place on Earth where the shield is dramatically thinner than everywhere else, stretching from the coast of South America across the South Atlantic Ocean toward southern Africa. There is a region where the magnetic field is roughly half as strong as it should be. Not slightly weaker, half. This is the South Atlantic Anomaly. Field strength, tilde 50% of normal area, half the size of continental Europe. Drift, tilde 22 kilometers westward per year. Think of Earth's magnetic field as a dome of protection. Everywhere else on Earth, the dome stands at its full height, deflecting charged particles far out into space. Over the South Atlantic, the dome dips, a vast dent in the structure. Low enough that the Van Allen radiation belts, the rings of high-energy trapped particles that normally sit well above the altitude of orbiting spacecraft, sag down toward Earth's surface in this region. Low Earth orbit satellites typically cruise at 200 to 400 kilometers altitude. The Van Allen belt's inner edge usually sits above that. Over the South Atlantic Anomaly, the belt dips down to the same altitude as those satellites, or even below it. So satellites that are safely above the radiation belts everywhere else on Earth are suddenly inside the radiation belts when they cross this region. They go from cruising in calm water to being hit by a wave they weren't designed for. Every orbit, every crossing, every time, and the anomaly is moving. Drifting westward at approximately 22 kilometers per year, growing larger every decade, and now doing something unexpected. So why here? Why this specific region of the planet? The answer requires going deep, literally to the boundary between Earth's mantle and its outer core, 2,900 kilometers underground. Normally, the liquid iron in the outer core flows in a relatively organized pattern, generating magnetic field lines that project outward from the core through the mantle and into space. Beneath the South Atlantic, something disrupts that flow. Scientists have identified what they call reverse flux patches, regions where the magnetic field lines are doing something they're not supposed to do. Instead of projecting outward from the core, they loop back into it. The field in this region is effectively running backward, canceling out the outward projecting field above it. Like crossing wires, the signals interfere. The net field weakens dramatically. What is causing the reversed flow? The leading suspect sits even deeper in the mantle. A massive anomalous rock formation called the African Large Low Shear Velocity Province. This is one of two continent-sized blobs of anomalously dense. Hot rock sitting at the very base of the mantle, the deepest layer of solid Earth. Scientists don't fully understand what these structures are or how they formed. But the one beneath Africa appears to be disrupting the convection pattern in the liquid outer core above it, distorting the flow of liquid iron in a way that creates reverse flux patches in the field. The exact mechanism is still being studied. What is confirmed, the reverse flux patches exist. The field is genuinely weaker in this region, and the structure causing the disruption appears to be a deep mantle feature that has been there for tens of millions of years, which means the anomaly may not be new. It may be a recurrence. A feature that appears when conditions align, and that possibility changes what it might mean for the future. Before we get to what this might mean long term, let's be clear about what it is doing right now, because the consequences aren't theoretical. They're already measured, already documented, already affecting systems you use every day. Every satellite in low Earth orbit crosses the South Atlantic Anomaly multiple times, per Dalton Y. As they pass through, they're hit with a significantly higher flux of high-energy protons than anywhere else in their orbital path. These protons don't destroy satellites, but they cause single event upsets. A particle hits a memory cell and flips a bit. 0 becomes 1, 1 becomes 0. That is a computer error caused by a cosmic ray. Space agencies and satellite operators know exactly when their spacecraft will cross the Sake, and many have procedures in place. Power down non-essential systems, switch to redundant backups, log the anomalies for analysis afterward. The Hubble Space Telescope's instruments experience glitches that correlate directly with SAA crossings. The International Space Station's computers have been documented experiencing elevated error rates in this region. And for the humans aboard the ISS, the anomaly isn't just a technical inconvenience. Astronauts passing through the SAA receive a higher radiation dose than during the rest of their orbit. Not immediately dangerous, the station's shielding mitigates the worst of it. But the exposure accumulates over a 6-month mission. SAA crossings contribute meaningfully to an astronaut's total radiation exposure. ISS crosses SAA several times per Dalton Y radiation dose, measurably elevated per crossing Hubble anomalies, documented SAA correlated. This is not a future problem. This is happening now, every orbit, every day, and the problem is growing because the anomaly isn't staying the same size. Data from the European Space Agency's Swarm satellite constellation. 3 satellites that have been precisely mapping Earth's magnetic field since 2013 reveals something that wasn't expected. The South Atlantic Anomaly is no longer a single unified weak zone. It is dividing into 2 separate lobes. The original lobe, the one that has been tracked for decades, remains centered near the coast of South America. A second lobe has emerged, faster weakening, newer, positioned just off the southwestern coast of Africa. 2 distinct dents in the shield, both growing, both drifting. NASA researchers tracking this split describe it as consistent with known patterns of magnetic field behavior, specifically the kind of activity seen in the geological record before previous periods of dramatic change. The field has weakened and split before. That is documented in ancient volcanic rock, lava that cooled and recorded the magnetic field direction of its era. Some of those records show the field becoming disorganized, multiple-lobed and globally weakened in the centuries before a geomagnetic pole reversal. That is where this gets harder to dismiss as a technical footnote. Earth's magnetic poles have reversed hundreds of times in the planet's history. North becomes south. South becomes north. The field flips. The last reversal, called the Brunhes-Matuyama reversal, happened approximately 780,000 years ago. The typical interval between reversals averages around 200,000 to 300,000 years. We are 780,000 years overdue by that average. Here is what scientists actually say about this, and it matters that we get it right. A pole reversal is not a sudden catastrophic event. It doesn't happen overnight. It takes thousands of years to complete, during which the field weakens, becomes disorganized, potentially with multiple magnetic poles simultaneously. It has happened before. Life survived. But the last reversal happened when humans didn't have GPS networks, satellite communications, power grid infrastructure, or any technology dependent on magnetic orientation. Right now, Earth's magnetic field as a whole has weakened by approximately 9% over the last 170 years. The South Atlantic Anomaly's growth and splitting may be a localized symptom of that global weakening, or it may be a temporary fluctuation. Both are scientifically plausible. Neither can be confirmed yet. But the swarm data shows the trend is continuing. The anomaly is expanding. The second lobe is intensifying. And the global field is not recovering. This isn't the end of the world. It is a process that has happened many times before and will happen again. But it is a process that this civilization, for the first time in human history, has built infrastructure that would be significantly disrupted by even a partial pole reversal. And the anomaly is the clearest current signal that something large is changing in the deep machinery of the planet. Let's bring this back to what you now understand that almost nobody else does. There is a region stretching from South America to Southern Africa, where Earth's magnetic field is half as strong as it should be. That weakness exists because deep Earth dynamics, liquid iron flowing in a disrupted pattern, influenced by a continent-sized rock formation at the base of the mantle, are generating reverse flux patches that cancel out the outward magnetic field above them. The result is a zone where the Van Allen radiation belt sags down to satellite altitude, causing measurable glitches in every spacecraft that crosses it. Every orbit, every day, the anomaly is growing from a data point tracked for decades to an area approaching half the size of Europe. It is now splitting into two separate lobes, a pattern consistent with what the geological record shows before previous periods of major magnetic reorganization. And the global magnetic field has weakened 9% in 170 years. None of this is cause for panic. The Earth has done this before. Life continued, but the machinery deep inside this planet is doing something. And the hole in our shield, visible in satellite data, measurable in radiation doses, documented in spacecraft anomaly logs, is the clearest surface evidence we have of whatever that something is. We live on a planet with a liquid iron core, constantly in motion, generating the field that makes our existence possible. And that field is not static. It never was. If you want to go deeper on what a full geomagnetic pole reversal would actually mean for modern civilization, GPS, power grids, satellite networks, aviation, and what the geological record tells us about how long it takes, that video is next. Subscribe so it finds you. I'll see you in the next one.